Video we're going to be discussing solving right triangles some more. This is the last video in my solving right triangles module, but we're going to get into some more complex examples, or at least a complex type of example in which there are maybe several unknown side lengths, and especially this example is going to be focus on what we refer to as either, you can call them embedded triangles or nested triangles. Okay, either way, you're going to notice that I've already drawn a diagram here. We'll talk about the measurements here in just a moment, but this would be maybe like a typical, very typical situation that I could necessarily set up with something made up, but that's no fun. Let's just go over the method, shall we? But what I want you to notice is this. You could almost interpret this as being two separate triangles, even though there are three. We say we got triangle ABD, okay, which is not a right triangle, so we're going to, in this instance, disregard it. But we have triangles ABC, so that it would be the overall kind of big triangle here, ABC, okay? And then we also have triangle BCD, okay? But the thing here is this, triangle BCD is embedded into triangle ABC. So, you know, they share at least the right angle down here. They share that on both triangles, okay? So, what do we know about these? Well, we know that angle BDC, okay, or CDB, but we know that is 54 degrees, and we also know this other acute angle over here is 38. Side length AD, or segment length AD from there to there is 32 units long. Segment length DC, we do not know. Maybe that is what we're trying to find, and it is what we're trying to find, okay? Or maybe we want to find H, okay? But you're going to notice this. We don't really have a lot to work with. So since we have two things that we don't know, and many other things we don't know, but two things specifically we don't know, the unfortunate thing is we're going to have to work with two equations. You know, two unknowns, you need two equations to go back to algebra. You know, you solve a system of equations. But we want to relate the same two unknowns. So the first thing I want you to notice here is this. Since we have H and X are the two things we don't know, we want to set up two equations involving both H and X, okay? Both of them simultaneously. So that's going to be our intent, okay? So that being said, let's go ahead and talk about some good practices here, starting with the fact that a lot of people have trouble looking at this triangle, okay, and necessarily digesting it all in one, when really we're exploring the two right triangles. So one recommendation I kind of, I'll make it to my students is this. If you have trouble looking at both the triangles together, we could necessarily call this, we say BAC, okay? We knew A to C, or excuse me, A to C. We say would be this entire side length over here from A to C. That would be like 32 plus the other X units, okay? So we say down here we'll write this is 32 plus X. I'm going to put parentheses around it just to show you that I'm associating those two together, okay? We also know this, side length BC was H units tall. Okay, and last but not least, we know this was 38 degrees. All I've done is draw the big triangle over here, okay? How about the nested triangle, okay? So the nested triangle had the same height, okay? And vertex B up here and vertex C down here was a right triangle, except it only went out to like here, okay? So I know I'm not drawing these to scale very well, but we said this angle here was, this was 54 degrees, okay? We knew the side length from D to C was X. We know this is H. Okay, so now looking at both of these triangles and having already stated our intent of coming up with two equations that would involve both H and X, since we have two unknowns, we need two equations to solve. But what we can do is we could set up a trig relationship between these very nice angles that are revealing themselves over here, and H and X. Okay, so since we're kind of observing these bottom acute angles here, and of course, it's a right triangle, so we could actually solve for the top angle if we were looking for it there. But in this case, we want to relate this 38 degrees to H and to X, okay? And in both instances, you're going to notice here that we're going to select the trig function of tangent, since tangent would relate both of these angles on each triangle to its opposite side and its adjacent side, which both involve H and X. So let's go ahead and set up both of our equations. So we'll start with EQ1. Okay, EQ1, I'm just writing this because it's good organization. But we say, let's look at triangle ABC first here, okay? So we say triangle ABC, we know this, tangent of the 38-degree angle, okay, would be its opposite side, or h, okay, over 32 plus x. So now we've already set up, and knowing that tangent of 38 degrees just represents a number, but we've already set up a relationship between h and x. So let's now head over here. We say, okay, so tangent in this instance, whoops, we'll go with green still here. We say tangent of 54, in this case would be opposite h over x. Okay, so now in both instances we have two equations that relate h and x together. So now we need to solve a system of equations. So the way, or the method we're going to use to do this is, let's choose a variable. And of course, we have two variables we don't know, h and x. Here's what I'm trying to say. In each equation, let's choose a variable to isolate that we don't know. So we can either get h by itself in this equation and h by itself in this equation. Okay, that's one way to do it. Or we could go back, we could say we'll get x by itself here, and we'll get x by itself here, okay? Either way, you're going to be able to solve this. However, you know, it is kind of something you want to talk about, is this idea of convenience. And so you'll notice that in both equations, h would be very, very easily isolated just by multiplying each side of the equation by the denominator. Okay, so over here it would look something like this. We say, okay, so 32 plus x on both sides. We'll take that times 32 plus x, that quantity, okay? And then we say we'll take both of these sides over here times just x, since that's all it had, times x. So I'm going to clean things up here a little bit. Here's what we got, and I'm going to go ahead and switch the sides around here. So now, you know, these cancel. We're left with just h. And h is actually equal to, I'm going to put the tangent of 38 degrees here in front. And I'm going to take that times 32 plus x. That's what we had. Now coming over here, okay, you notice we got x times tangent of 54, but these x's canceled. I'm going to switch these sides around as well. We say, okay, so h in this instance, h equals x times tangent of 54 degrees. So you might be saying to yourself, why is this crazy guy asking us to get h by itself in both instances? Well, if there's one thing in algebra that's overwhelmingly clear, it is the fact that something equals itself, okay? I think we call that reflexivity. I could be wrong. That might be where you switch the two sides around. It's sad. I'm a math teacher and I'm having a hard time remembering that one. But, yes, something equals itself. So trust me on this one. But since h equals h, what we could necessarily say is this. You know, when we say h equals this and h equals this, it's also this idea of transitivity. But we say, why not take both of this, these sides here, these two sides, and set them equal to one another, because since they both equal h, then they must both equal each other. So here's where the fun algebra gets to come in. You know what, we're going to do a little bit of simplifying before we start. Starting with this, let's take this tangent 38, okay, and we can get a number for it. So let's pull out the calculator. We can change it to a decimal. Tangent of 38 degrees, and it's going to tell us it is 0.781-ish, okay? So now just cleaning this up, that's all I'm doing. We say h equals 0.781 times 32 plus x, okay? And the reason why I did that is because now we're going to distribute this, and it's a little bit less writing. So let's take 0.781 times 32. We say 0.781 times 32. If you're taking a trig class, get used to your calculator. It's your friend, okay? 24.992. So we say h is equal to, now we got here 24.992, okay? Now that is plus, we have to distribute the 0.781 over to the x. So we say 0.781x. So we got h over here, and over here we say h equals x times tangent of 54. So maybe we find tangent of 54. We say, okay, so calculator, dear calculator, we say tangent of 54 degrees, and it says, would you like to buy the calculator? We say no. We say continue the trial. 1.37, and the 6 will stay a 6. Okay, so 1.376. So we say h equals 1.376, okay, x. So all we've done is kind of clean these up a little bit. We got decimals instead of the trig functions of the angles. But we said we were going to relate these two just by setting them equal to one another. So try and bear with me here. I know I'm trying to squeeze this in the screen. But we say, okay, so let's put this h over here. We'll make it the left side of the equation. Okay, so we say 24.992 plus 0.781, excuse me, x. That's our first h, okay? And that's equal to h, of course. So since we wrote that down for h instead, we'll write in this case, instead of h, we'll write 1.376x. Booyah. So now, since our intent is to get x by itself, okay, I know there are lots of decimals floating around here, but here's what we'll do. We'll get all the x's on one side. Be simpler to just go ahead and kick this one over to this side. So we'll subtract 0.781. I'll be explicit on this step. Minus 0.781 from both sides. X, okay. And so we're left with this. 24.992 is equal to 1.376. 1.376 minus 0.781. We get this, 0.595. Okay, so 0.595. So, and that's an x, by the way. We need to isolate x still, so what we'll do is we'll divide both sides, if you can see this here, by 0.595, 0.595. I'm really trying to squeeze this in here. But we should have x then, so I'm going to go ahead and transplant our answer over here, but we say x is approximately equal to, squiggly squiggly, okay, 24.992, so we got 24.992 divided by 0.595, and we earn a value of 42.003. Okay, so we say 42.003 units, but let's do some good habits still. Okay, that was a lot of work, I know, but that's the method. We want to be able to relate h and x together on two different triangles. We get two equations and go through that whole protocol right there. But now that we know x, of course, this is the part where we race back up to one of these triangles and plug it back in, or both spots. We could put it here. Okay, whoops, didn't want that. We could put it here for this x right there and triangle ABC, or we can put it in here on the second triangle. Both triangles have an h on it. Of course, we want to find h. So we say since x is approximately equal to 42.003 units, at this point we could just set up a relationship between the 54 degrees with h and x involved. And of course, this was something we already did. We said, hey, tangent of 54. You know what? That was equal to opposite over adjacent, and we didn't know h, and we didn't know x either, but now we do. So we say, so 42.003, and so to solve this, we say 42.003, we'll multiply both sides by that quantity, times 42.003, trying to squeeze it in there. So we have h is equal to 42.003 times the tangent of 54 degrees, and now we just ask the calculator to take 42.003, oops, don't need that, back, times tangent of 54 degrees, and it says 57.812. So we say h is approximately 57.812 units, ish. Whoops. So we were able to find x and h, but the important thing to remember here is, draw two separate triangles and relate h to x, or your two unknowns to each other in two separate equations, and then let's solve a system by isolating one of those unknowns and then setting it equal to itself.